Welcome to this lesson on AP Calculus. In this lesson, you will learn about the properties of limits and how to use direct substitution as a strategy to find the limits. You have seen how to find the limit of a function using a graph or a table of values. Now, we will go over how to calculate the limit of a function algebraically using the properties of limits. And look at the limits. Look at the limit laws in this image. Now, let's use these laws to evaluate the limit as x approaches for limits x as x approaches for of 3x squared minus 2x plus 1. Now, using law 1 and 2, you can break the limit into 3 smaller problems. So we can break apart the polynomial and have the limits as x approaches for of 3 squared and the limit as x approaches 4 over 2x and the limit as x approaches 4 over 1. Next, we can use law number 5, which tells us that we can move a coefficient in front of the limit. So by doing this, you get 3 times the limit as x approaches 4 of 1, x approaches 4 over x squared, and minus 2 times the limit as x approaches 4 of x plus the limit as x approaches 4 of 1. Now, by using law 8, the limit as x approaches 4 of x squared can be simplified by plugging in the 4 in for x. So here we get 4 squared is the letter color 4 squared. Now, per law number 6, the limit as x approaches 4 of x is equal to 4. And the limit as x approaches 4 of 1 is simplify 1. So now we just have to simplify this and add and subtract, and we get 3 times 16 minus 8 plus 1. So we calculate, we get 41. So the limit as x approaches 4 of 3 squared minus 2x plus 1 is equal to 41. Next. In this problem, we want to find the limit as x approaches 3 of 2x plus 3 over x minus 1. Now, in the previous example, we took a polynomial, we took our problem, and we break it apart and found the limit of each individual term. But in the end, all we did was substitute the value of our limit, the x, into our function. So this is what we are gonna do here. We are gonna let our function equal, or our limit equal g of x. So we have g of x is equal to 2x plus 3 over x minus 1. And we are gonna substitute, or we are gonna evaluate our function when x is equal to 3. So we are gonna find the g of x, g over 3, which is 2 times 3 plus 3 over 3 minus 1. And when we evaluate these, we get 9 over 2, or 4.5. So the limit as x approaches 3 of 2x plus 3 over x minus 1 is equal to 4.5. And this is called direct substitution. And this is the first strategy where we can find the limit analytically, algebraically. So in general, if C, which is the limit, if C is the domain of a polynomial or rational function, then the limit as x approaches C of f of x is equal to f of C, meaning that we can sometimes plug in our value of our limit into the function, and if we get an answer, then we just find our limit. Let's see another example. Here, we need to find the limit as x approaches minus 1 of 2x to the third power plus x minus 1 over 9 minus x. So we're going to go ahead and use direct substitution to evaluate this limit, since minus 1 is in the domain of this function. So to find the limit as x approaches minus 1 of 2x to the third power plus x minus 1 over 9 minus x. We're going to simplify, substitute minus 1 in the for x. So we get 2 times minus 1 to the third power plus minus 1 all over minus 9 minus 1. 9 minus minus 1. So let's simplify the numerator. So we get minus 1 to the third power, which is minus 1 times 2. We get minus 2. Minus 2 plus minus 1 is minus 3, and subtract 1, we get minus 4. Now, in the denominator, we have 9 minus minus 1, negative 1, so we end up with 10. Simplify this to minus 2 over 5, if you need to. Now, once again, if the limit is in the domain of the function, then you can use direct substitution to evaluate the limit.